Dear Professor, our group from Vietnam, we are very happy to perform you our work with the title Magnetic and Magnetocaloric Property for Perovskite Material. First of all, we make an introduction. Nowadays, there's a lot of cooling equipment requiring a material which requires the room temperature. Many groups have studied lanthan, mangan, oxide 3 by doping calcium, magnesium, strontium on both A and B side, but didn't come up with one with a Curie temperature can acquire the room temperature. Our main aim is study magnetic and magnetocaloric for our compound by doping calcium into lanthanum, magnesium to find the optimal concentration which have a highest entropy change.
Now, we would like to move to experiment. As you can see, the samples were prepared in this by ceramic method in this profile. The measurements are exactly same, VSM and ppms.
Moving to the main part, I would like to give you a detailed look about our project. Figure 1 shows the XRD patterns of our compounds. All the samples are single phase. It do not appear any peaks of strain phases. All the peaks are sharp. The crystal structure of the sample is cubic. While increasing the X content, the lattice constant of all samples increases. It results in the expansion of the crystalline average sizes, but gets the maximum value at the X equals 0.4. Figure 2 is the SEM images of all samples. They are rather porous. The size of the grains are quite equal with the crystalline size of 100 nanometers, which are approximate to the crystalline average size calculated from the XRD patterns. Figure 3 is the magnetization curves versus the temperature measured at the magnetic field value of 0.05 Tesla. Figure 4 is the dm per dt versus temperature. Both figures show that the Curie temperature remarkably rises from 150 to 276 Kelvin while increasing the barium content from 0 to 0.4. But the Curie temperature decreased 4 Kelvin at the X value of 0.5.
Figure 5 shows the magnetization curve the magnetic field for our compound at the room temperature. When the container is increased from 0 to 0.2, the magnetization curve are paramagnetic. The container is varied from 0.3 to 0.5. The sample are ferromagnetism. It reaches the maximum volume at X equals 0.4 and decreases after increasing X to X equals 0.5. The figure 6 is the kappa and kappa minus 1 versus temperature. By looking at the kappa curve, we can see the sample are either paramagnetics or ferromagnetics. Because of a wide range phase change of the X, kappa minus 1 only 90 at high temperature. The Curie temperature reached the maximum volume of 276 Kelvin, which is nearly the same volume with the temperature we can calculate from dm per dt.
Now move to figure 7, which provides the set of isothermal curves in the temperature range from 100 Kelvin to 319 Kelvin. Magnetic values show a large variation in intensity around the Curie temperature. At the lowest temperature and low magnetic value, the magnetic field increases strongly and tends to saturate when the magnetic field is larger than 1.5 Tesla. Figure 8 is the temperature dependence of magnetization in various fields from 0 to 5 Tesla. We can see that the magnetic value has a large change in the temperature range from 250 Kelvin to more than 300 Kelvin, in which the value of Curie temperature is approximately 276 Kelvin, calculated from the minimum point of the derivative dm per dt curve. Figure 9 is the temperature dependence of the magnetic entropy change for different applied magnetic field changes and the applied magnetic field changes dependence of the maximum entropy change. The maximum value of the entropy change is proportional to the rise of the external magnetic field. It can be easy to see that all the peaks are at the same temperature, which is approximately 276 Kelvin.
To summarize, we have succeeded in preparing the perovskite material, which almost reaches room temperature. Our results show that the sample is single phase and the crystalline size is at the maximum value. Optimal concentration is 0.4, which provides us with a compound with the highest entropy change. The maximum temperature is 276 K at the barium content value of 0.4. This is the optimal condition to reach room temperature. On behalf of my group, thank you very much for listening.